So now we're going to get into actually using those conversion factors to do some calculations. We kind of previewed this a couple times, but here we're going to do it for real. And so they go through here, and if you look at the printed versions on the of the PowerPoints or just the online versions here, the slides aren't hidden the way that I'm hiding them here as I'm working these out. They use these steps over multiple slides to show how to work out the problem. I'm going to do that as well, but I'm not going to specifically state that, here's what I'm doing at this point in time. But when it comes to a problem, one of the things you want to do is what unit are you given and what unit do you need for your final thing? And identify those, and then write they have write a plan that converts them. Really, I just identify the conversion factor and plug that into the calculation. From there, decide which way you need to flip the conversion factor, and then actually write it into the problem, and then you have your calculation set up, and at that point it's ready to punch into a calculator or work it out by hand if you want. But for example, we'll do this one. So a person weighs 147 pounds. I'm going to call that their weight, and we want to know what their mass is in kilograms. And so this is how I'll tend to set up a problem. I'll label the numbers given by what they are. Frequently, they'll be abbreviated in some formula somewhere. That's not going to be the case here, but I'll still label what they are, and then I'll label what I want to know, and I'll at least put an equals question mark there. A lot of times I will put that symbol as well for it, and then equals question mark. And from there, if you're given multiple numbers, you may have to decide which numbers you're starting on. When you're only given one number, the problem has to start with that one number. So we have 178 pounds, and we want to end up at kilograms out here somewhere. Now, it turns out that this one's only going to take one conversion factor, but I usually give my self space to write. And when I'm showing how to work these out, I frequently will do my units out there like that. When I'm personally doing them, I won't have that. I just know from what I've marked up here in the problem that I eventually want to end up at kilograms. But for our purposes here, I'll go ahead and show that. And it turns out I've given myself too much space, but you might have 2, 3, 4, maybe more conversion factors you need to squeeze in there. I definitely always recommend pencil for calculations as well, just because you're going to make mistakes, and you want to make it as easy to read for someone who's going to grade it as possible. Anyway, 178 pounds, and we happen to know that 1 kilogram is 2.2 pounds. And so then I need to use this conversion factor, and I want my units to cancel out. I want to play that diagonal dominoes thing, or what's properly called dimensional analysis, and I want to analyze my dimensions, and dimensions is just another way of saying units. I want to analyze my units. And so if I want the pounds that's here in the numerator to cancel out, I'm going to have to put the pounds on my conversion factor in the denominator, which then automatically means the kilograms has to go in the numerator. Then from there, I plug in the numbers here, 1 kilogram and 2.2 pounds, and at that point, I can cancel out my units. And then I'll cancel out my units. I've switched pen colors here. When I'm working this out by hand with pencil, I'll change what kind of slash mark I use. And so I might go diagonal up and then diagonal down, and the next time I use X's, and then I might scribble it out, and then I might scribble it out. I just keep canceling out my units with different symbols. That way I can keep track of making sure that did all my units actually cancel, and did I end up at the units I want? Yes, I ended up at the units I want. If my units come out properly, as long as I'm using true conversion factors, as long as those two are actually equal to one another, and I've not swapped my numbers, I can guarantee I have it set up correctly. And if I have it set up correctly, at this point, it's just punched into a calculator. So I'm actually going to go ahead and put an equal sign here, and it turns out that when you punch this into a calculator, you're going to get 80.90 repeating kilograms. Well, we're going to round off to 2 sig figs here because our conversion factor limits us to 2. Really, I probably should have pulled in a conversion factor that had an extra digit there so I could use my original 3 sig figs there, but that's going to round off to 81 kilograms. If I had used, say, 2.2, I think it's 0 is the next place value there, then this would have rounded off to 80.9 kilograms with 3 sig figs. So there's a 2 sig fig answer, and there's a 3 sig fig answer. Here we have another problem here that a rattlesnake is 2.44 meters long in meters, and I want to know its length in centimeters. And so really I'm just changing the units here on this one. I mean, that's all we're ever doing is changing the units, but I'm measuring the same thing, a length and a length, in very similar metric units. Now, if you know the move the decimal trick, you can just move the decimal here. I do want to show how to set this up the dimensional analysis way. So I have 2.44 meters, and so I know as I go to do a conversion, I'm going to need meters on the bottom here. I usually don't write out the equality. I personally will just put those into the conversion factors. There's a bit of a gamble that if you're remembering it wrong or you switch the numbers, you switch the units, and so it never hurts to write those out, but I personally usually don't. Anyway, my question at this point is, I know I want meters here so that my meters cancel out, and the question is, can I take meters directly to centimeters, or am I going to need another conversion factor? And the answer here is yes, I can. And so since I can do that, I'm just going to put centimeters here on the top. Then I just need to plug in the numbers. 100 centimeters is 1 meter. My units cancel out. I'm left with centimeters like I want. I'm good. And so now I just punch that into a calculator, and I get 244 centimeters. This here, if I'd put the decimal here, we'd say that this is exact, and then we are going to use the 3 sig figs here to limit us, and that's exactly what the calculator gave me, was 3 sig figs already, so I don't even have to worry about doing sig fig rounding there. A lot of times you have to do multiple steps, as I've kind of hinted at, to go from your initial units to your final units. Here we're going to be working with ones that just have 2 steps, but it could be more steps. And so let's take a look at a calculation like that. A doctor's prescribed a dosage of 0.15 milligrams, so I'm going to label that as dosage of synthyroid. Thyroid, anyway, it doesn't matter. If you have only 50 microgram tablets in stock, how many tablets do you need? So here we're given 2 numbers to begin with, and we're going to have to decide which of these is the one we want. So this one here is the dosage, and that's what I'm going to start with. It's also the first number given to me, which makes it more likely that it's the number I want. In reality, what's going on here, though, is that I only have the 50 microgram tablets. Well, that is 50 micrograms per tablet. That's a conversion factor. And if I'm given a conversion factor in a problem, I don't start with that unless it's the only thing that I'm given. This happens sometimes with density specifically, but I tend to save conversion factors for using in the calculation. So I'm going to start with the 0.15 micrograms. The nice thing about dimensional analysis, by the way, is as long as you're careful with making sure your units cancel out, even if you start with the wrong value, you can end up at the correct answer. And so we should be good here. 0.150 milligrams. And so I want to get rid of the milligrams first, and so I'm going to have milligrams on the bottom. This unit doesn't work because it's micrograms, and so I need to see, can I get milligrams into the same into micrograms? And the answer is yes, I can, because I know that 1,000 micrograms is 1 milligram. And so that takes care of canceling out those units. And now I need to get rid of micrograms because I want to know how many tablets. I didn't actually label that at the beginning, but how many tablets is what I want to figure out in the end. And so then I know that I need micrograms here on the bottom to cancel out my units, and I want tablets in the end. And this one here, we're given micrograms and tablets on our conversion factor, so that one's going to work. That 1 tablet has 50 micrograms. And so then at this point we punch it into a calculator and you get 3 tablets. And I will point out that since we're talking tablets, we're going to want whole numbers for those. That is an exact number, and we're not going to worry about sig figs on this one. Yes, of course, you can split pills, but we're not going to tend to do that in a medical setting. And in addition to that, we got a nice, neat whole number answer here, so we can stick with an exact value on this one. I did mention already that as long as you are careful to make sure your units cancel out, you know that you have it set up correctly, and that it does work out even if you don't start with the correct value. But real quick, I want to prove here that my units cancel out. Notice I'm using the different slashing marks, even though I have the ability to change pin color, and I'm left with tablets in the end, which is what I want as my answer. There is one minor exception to always getting to the right answer, and I want to show what happens when you do that. If you didn't know, or you made the wrong guess, and you guessed that you wanted to use this as your value to start with, well, if I started with 50 micrograms per tablet, that would have been the wrong way to approach this problem. One thing that's kind of a warning flag up front is that tablet is on the bottom, and I want tablets in the end as my units, which should be in the numerator. It should be on top. But sometimes you're not given that conversion factor, and it might be a couple steps later before you discover that you put that unit in the wrong place. I think specifically of when we get to doing calculations with solutions, we'll have a unit called moles and a unit called liters, and sometimes we end up putting the volume measurement, that liters, in the wrong place. That's probably where I've made this mistake most often, and so I want to show how you can recover from it real quick. Well, at this point, if you're working out the way I am and you're not writing out the individual equalities, but you're just trying to cancel out your units, well, I can see I've got micrograms there. I know I need to cancel out micrograms, and so what could I do? Oh, I could do 1,000 micrograms is 1 milligram. Great, I have milligrams. How can I get rid of that? Oh, well, I'm given this number here in the problem. So then I'm going to multiply by 0.150 milligrams. And I don't really have a number to do there because this isn't a conversion factor, but of course that's just an invisible 1 there. And if you want to draw that in, of course, I would even do that myself. And then let's see here. If I cancel out my units, micrograms cancels with micrograms, milligrams cancel with milligrams, I'm left with tablets. But when I go to do this calculation, I'm going to end up with the 0.3 repeating per tablet. Well, my units are in the wrong place. That's not what I want. You've got two options at this point. Option number 1, come back through here and literally flip every one of these ratios. Flip that one, and flip this one. And then you'll notice it'll be in a different order, but this one here matches that one there. This one here matches the one directly above it. And that this one here matches that one there when you flip all those. They're in a different order, but order of operations in algebra says it doesn't matter what order you multiply all those. And then you have it set up properly and you can punch into a calculator again. The other one, and this is the one that I find students are less comfortable with doing, but the other option is I know I have this all set up exactly backwards, and so if we ignore the going through the flipping, because we're going back to I made a mistake, how do I fix it? The other option is I know all those need flipped, and the way that you can flip this answer here is by raising it to the power of -1, which is really easy to do on your calculator. And when you do that, it will flip numerator and denominator here. I'll put 1 tablet per 0.3 repeating is what your calculator will do when you do that power of 1 there. And then it turns out that it will also give you the answer of 3 tablets. And you'll be correct. So either method works. I'll tell you that most students, when they recognize that they have the units wrong here, they will come through and they'll flip every one of these and get it. But this is a shortcut if you did happen to set it up wrong. And as long as you show me that that's what you did, that you do some kind of, I raised this to the power of -1, and that's how I got it from there to there, I'm happy with that. If you actually want to show what that comes out to be by flipping it yourself instead of letting the calculator do it with raising it to the power of 1, that's fine as well. But I can do partial credit for you showing your work if you do that. If you don't do that, there's nothing I can do to help you, unfortunately. If you get the wrong answer and you don't show me your work, then you just have a wrong answer. So anyway, that's how you can recover from that mistake. But like I said, it doesn't matter which of these you start with. You could have started with the tablets like this and then done these 2 conversion factors, which would have been the same as the orange and green one down here, again, after we did that red flip, and you end up at the same answer. On the next one here, we're asked to do 1.6 days is how many minutes. So I'm given days, and I want to end up at minutes for my units. So we can do the conversion. Now, maybe you know how many minutes are in a day. I don't. So I'm going to do multiple conversion factors. I know I want days down here on the bottom. What can I turn days into? Well, I don't know how many minutes are in a day, but I do know how many hours are in a day. And so I'm going to put hours up here. Now I plug in my numbers. I know that 24 hours is 1 day. And then can I do hours into minutes? Well, sure enough, I can. Hours into minutes. And so then I know that there's 60 minutes in 1 hour, and I can get my answer here now, punch that into a calculator, and I get 2,304 minutes. And because this has 2 sig figs and both of my conversion factors here are exact, and as long as I put a decimal there, they both have 2 sig figs as well, then I'm going to round this off to 2,300 minutes. And I think you would agree that if we're talking about 1.6 days, or even if we just go with 1.5 days, we don't really care about those 4 minutes. 2,300 minutes is more than good enough. As a side note, the textbook here is only practicing doing 2 conversion factors, but let's say you wanted it in seconds instead. If the problem would ask for seconds, well, maybe you know how many seconds are in an hour. I've eventually learned it, but I didn't know it when I was a student. I just did the next conversion factor. That 1 minute is 60 seconds. And then my minutes canceled out, and I was good there. And I always like to show that my units do cancel out and not just trust it. So here we have the days canceling out, the hours canceling out, the minutes was what we are left with on the original problem. If I'm going for my modified problem where I've changed it to calculating seconds, then my minutes cancel out with my minutes here, and I'm left with seconds, which is what I was looking for. And so we're good. As a side note, I didn't actually punch this into a calculator previously, and I'm not going to waste the time to do it now. I'll leave that as a challenge to you to go ahead and finish that conversion. And one final one here for practice in this section, we have 65 meters per minute is what you're walking on the treadmill. And so then that's a meter a minute, roughly 3 feet, 1 yard a minute. That's a decent pace. But 65 meters per minute, that's my speed, or they call it a pace, so we'll call it a pace here. And we want to know how many minutes does it take for you to walk a distance of 7.5 kilometers. So even though 7.5 kilometers is the goal, that's the distance I want to go. That's the value I'm going to start with. A lot of times you'll think to yourself, oh, the thing I want to end up with is 7.5 kilometers, so that's what I should be aiming for. But no, we can start with the end in mind. And so 7.5 kilometers. And then this here gives me meters, so I'm going to have to get my kilometers into meters. So I can do that, kilometers, meters, and I know that 1,000 meters is 1 kilometer. And now I can then use that pace at 65 meters per minute, but I'm going to flip that so that my meters is on the bottom, so my meters cancel out and my minutes are up here. And so then I know that in 1 minute I can go 65 meters. And real quick here, just to confirm, our units do cancel out. Kilometers cancel to kilometers, meters cancel to meters, and we're left with minutes, which is what we want to solve for. So I know I have it set up properly, and once I do that, then I can punch this into a calculator, and I get 115.38, and that actually goes on minutes, which means that's that. I've got 2 sig figs here and 2 sig figs here, and my conversion factor is exact. And so then because of that, I'm going to round this off to 120 minutes. And I'm not going to put a decimal here at the end to emphasize I only have 2 sig figs. Of course, you can go the scientific notation route as well to show it, but I think that's a little obnoxious for this kind of number. Anyway, that finishes this section.